Now we'll actually start adding expressions. Now that we know how to find the common denominator, we'll start adding expressions. So it gives you the steps here. It's the same thing. The first step, just like when you add numbers, is to find the least common denominator, and then whichever expression does not have that as a common denominator, you multiply the top and the bottom, just like how you do for numbers. The only thing here is you have restrictions, okay, because it's a rational expression. So when we actually start doing the work, you want to make sure that you are writing the restriction. So you want to always write the restriction before we simplify. Okay, I'm skipping 12 because it's numbers. I think we all know how to add numbers. We did some exercises in the previous class. We are going to jump to 13. I'm going to do the first one with you, and then you guys will do a couple by yourself. So remember, your first step is to find the least common denominator. And to find the least common denominator, the step is take every denominator in each of the rational expressions and write out all the factors. So 6x can be written as 3 times 2, and x can be written as x. We good? And then 8x. 8x is 4 times 2, but 4 can be further written as 2, 2, 2. So it is 2 times 2 times 2 times x. So write all the factors. And now let's find out what is going to be my least common multiple. So for my first expression, I take all of them. I take 3 and 2 and x, because there's nothing to compare it with. And then I come to my second expression. There are 3 2's and an x. I know I can definitely leave out the x. I don't need the x. I already have one x. There are 3 2's here, and I actually have only one 2, which means I need to take 2 of the 2. So I will take 2 more 2's. Because you want every rational expression denominator to be represented. So this one has 3 2's. I have only one 2. You need to write the other 2's also. Okay. So that means my LCM is 24x, which sort of sounds correct because 6 and 8 are both multiples of 24. 6 times 4 is 24. 8 times 3 is 24. And then x is x. There's one. Well, you need that one x. Now what are you going to do? You're going to convert each of the expression to 24x. So 7 over 6x multiplied by so you need 24x. So what do you multiply with 6x to get 24x? I already have an x, I just need a 4. This is now going back to adding fractions, just like how you do with numbers. Is everybody with me? Everybody okay? Yeah, and then plus 5 over 8x. What do I multiply with 8x to get 24x? I already have an x, so I just need 8 times 3. So my denominator I already know. My numerator is going to be 28 plus 15, which is 28, 38, 43 over 24x. Is this simplifiable? Not really. And restriction is x. I didn't simplify anything, so I can remember to write your restriction before you simplify. Okay, I'm going to let you guys work on 14 by yourself. If you just follow the steps, it should be okay. So I've just shown the LCM. Did everybody get LCM to be 20x squared? So from my first one, I've taken everything. First one, you take everything. 2, 2x and x. Second one, I have to take 5. 5 is not represented, but I don't need to take the x. Which looks correct sort of, because 4x squared can be multiplied by 5 to get 20x squared. 5x can also be converted to 20x squared. And there's nothing lower than that I can take. Okay, now go ahead and add the expression. Is everybody clear about this? Any questions? Yeah. So this is the LCM. Now please add the expressions, making sure you're able to. Before I do any simplifying, okay, I'm not done completely, but this is a good step for me to stop and talk about the restriction, right? So at this stage, before I do any simplifying, I can see that my x cannot be equal to 0, so that's the only restriction. I don't see any other restriction. Can I simplify this further? What do you guys think? I do see that in my numerator I can pull out 2. They're both factors of 2. And denominator also 20 is 10 times 2. So I can pull 2 out and simplify this further. So this will be 2, 15 plus 4x, and this will be 2, 20x squared. 2 times 10x squared. So this cancels out. So this is my simplified form. Yes?
Could you simplify it at the beginning with the 6 over 4x squared?
Yes. But the only thing is you want to make sure that you will simplify it after you get the common denominator, or because
I had a common denominator of 10x squared after I simplified.
Okay, so you simplify it right in the beginning. Okay, perfect. Yeah, absolutely. Okay, yeah, good. I didn't even notice that. Yeah. So you'll land up with this without even having to, right? Yeah, awesome. Yeah. Yeah, so she basically said she simplified this right in the beginning, 3 over 2x squared, which is actually the right thing to do. I completely missed that. Yeah, we can do that. All right, if everybody's good with 14, we will do, which one shall we do? Let's do 15. Okay, I want to do 15. Everybody okay? Can I move on to the next? Okay, I want to do 15 because I don't know if you guys can notice, this was addition. We did a couple of addition. 15 is subtraction. So I just want to make sure that we are kind of subtracting correctly, because sometimes I feel students forget to distribute the subtraction when you're writing the numerator. So let's go ahead and do this. It's the same thing, except instead of saying plus in the numerator, you'll subtract the two expressions. So let's go ahead and do the same thing. You'll still find the common denominator. You'll still multiply the top and bottom with whatever is missing, and then finish it up. So I can see, I didn't even have to write this, I'm just writing it because I'm showing it to you, but I can see that x minus 3 as a factor and x plus 2, there's really nothing common. So I have to take both of them. Sorry, x minus 3. So this is your LCM. That means what do you multiply my first one to get this? Five has x plus 2. That means I multiply top and bottom with x minus 3. So my common denominator is x minus 3, x plus 2, and then just simplify the numerator. Okay, so this is why I want to be careful. So don't do the subtraction, just write it out here. Minus 5 times x minus 3. And then distribute the negative sign. And then distribute the negative sign. So my restriction, I'm going to go ahead and write the restriction here. At this stage, before you do anything, we can write the restriction. X cannot be equal to, from negative 3 I get positive 3, from positive 2 I get negative 2. This is my two restrictions. Okay, and then all you're going to do is simplify the numerator. There's nothing else to be done. So 3x plus 6 minus 5x, negative 5, negative 3 is positive 15. So this is one place I do find students making a mistake, because I think they distribute the 5x minus 15 and forget that it's negative of that. So it does plus 15. Okay, so that's why I prefer to write it here, so you can make sure that you're distributing the negative correctly. That's the final answer. Yeah, very good. So the restriction is on the top here. X cannot be equal to 3 and negative 2. I hope everybody can see. And then the final thing is negative 2x plus 21. Okay, I'm going to leave this up for 2 minutes so you guys can. Any questions? No, we're all good. Okay, let's do 17. 16 is also good, but between 16 and 17 I'll pick 17. I think you guys are doing well, so one more is good. So let's do 17. Again, I'm going to let you guys do this by yourself, do the whole thing by yourself, and I'll put up the work in a couple of minutes, or 3 minutes, or 4 minutes, or whatever, how much ever time it takes. So we're all working on 17. So just follow the steps. If you follow the steps, it should not be difficult. First step is to find the common denominator. So factors of 32 that add up to negative 12, in case you're not able to, it's negative 8 and negative 4. So I'm just putting up the first couple of steps. Your LCM should have been x minus 8, x minus 4. We're good? Okay, and then the first rational expression you don't have to multiply with anything because it already has x minus 8, x minus 4. But the second rational expression has only x minus 8, so you multiply the top and bottom with x minus 4. Are we okay so far? Okay, now go ahead and so then you write the common denominator and then simplify the numerator. So I'll give you guys another minute or two to do that. I wasn't collecting it. I just discussed it. So thanks. Sorry. Yeah.
Okay.
Yeah. I decided not to. I'm just writing the final answer. I will show you the work, but those who are done can check. And I'll show you the work in another, give you guys another minute for those who are not done. Yes. Oh, sorry, 4. Yeah. Thank you.
I have a question.
Oh, you had a question. Okay, either one. Yeah, go ahead.
Can you simplify it further on the numerator or no?
I didn't even try. I think maybe you can, right? It looks like negative 12 factors of negative 12 that add up to negative 11. So negative 12 and positive 1. And it's factorable?
Yes.
Yeah, okay. So if it's factorable, yeah,
Okay.
then go ahead and factor it, yeah. But does it cancel out?
No.
It doesn't cancel out, so just factors.
Yeah.
I didn't even try, yeah, okay, yeah. So it's a good idea to factor, but I haven't tried factoring it. Yeah, oh yeah, you had a question, sorry, yeah.
For the first term on the numerator, can you try from the
Yeah, sure, absolutely. Yeah, let me show you the whole work, yeah. So let me go ahead and reduce it a little bit so we can see the whole paper. Okay, this is the entire work. So step number 1 to find the LCM. I'm not sure which one where you had a question. Well, the LCM is okay?
Yeah, the algorithm is good. I just wanted to know how you multiply x minus 4 and x minus 8 to x squared plus x.
How you multiplied. So I didn't multiply. I left them as factors. Is that your question?
On the numerator.
On the numerator. So this one, so I just took x squared plus x minus 3 as this. And then this side is just 3x times x minus 4. Because you're multiplying the top and bottom. I made a mistake. No. So you're multiplying the top and bottom with x minus 4.
Okay.
Right? So 3x over x minus 8 is already there. You multiply top and bottom with x minus 4. Does that make sense? So all you're doing is 3x times x minus 4. Yeah.
On a test or a quiz, if we get a polynomial, or if we get like an equation in the numerator, do you want us to factor it factorable? Or
Yeah, we should be factoring it because the reason why we factor is because in case something cancels out, you want to write it in the simplified form. So we should be factoring it. So it's my mistake. I should be factoring this. Yeah. Serena, did I answer your question? Yeah, okay, awesome. Anyone else not sure of these steps? So this can, I believe, can be factored further. You should factor it, but it doesn't get simplified. The factors don't have anything in common with x minus 8, x minus 4. So for now, I'm just leaving it as it is. Anybody else with any other questions? Okay. Can I close this? Is everybody comfortable with adding rational expressions? So you find the common denominator by the method that we talked about, where you write down all the factors, take only those, all the unique factors. You don't take anything that's repeating. But every rational expression should be represented. And then multiply each rational expression with the denominator that's missing, and then just simplify. All right? Okay. So then I'm going to do the next topic, which is, let me stop this so that